everyone, we're going to verify the following trig identity by simplifying, multiplying by the conjugate. It's a bit messy. So the first thing I'm going to do is write this with parentheses. So I have sine of theta minus cosine of theta, put that in parentheses, plus 1. Divide it by, and do the same thing for the denominator. Sine of theta plus cosine of theta minus 1. Put this in parentheses. Now what I'm going to do is multiply the denominator by the conjugate. So that means I'm using this, and we have this a minus b. So I have a minus b, and I want to multiply it by a plus b. So I can write this as a squared minus b squared. So my a equals sine theta plus cosine of theta, and my b is 1. So the conjugate, when you multiply it by the denominator, you just write the same thing, your a plus cosine theta, then you're going to write plus 1. The thing is, you're going to also have to do the numerator the same way. So it's going to be sine theta plus cosine theta plus 1. All right, now, after you do that, we get our denominator is pretty easy. You're just going to do your a squared minus b squared. So that's just going to be sine theta plus cosine theta, square it, minus 1. The numerator is a little harder. So basically, we have to FOIL this out, and you're going to get, when you do this one, you're going to get sine squared minus cosine squared. You just FOIL all this out, plus sine theta plus cosine theta. Then we have another plus sine theta minus cosine theta, and then plus 1. All right. After we do that, we're going to simplify the numerator and expand the denominator. So basically, when you do that, what I did is I multiplied these two for the numerator by FOIL method, and then I did this part. All right, so let's get the numerator cleaned up and expand the denominator. So that's going to be sine squared theta minus cosine squared theta. I'm just canceling things in the numerator. There were 2 sines. Then we had plus 1. Now my denominator, we had, what was that? I forgot what we had in the denominator. Sine plus cosine theta squared. And then we had the plus 1. So basically what you're going to do with that, or it was minus 1, sorry. We're using this perfect square trinomial. So we're going to do that. And that's going to give us sine squared theta plus 2 sine theta cosine theta, and then plus cosine squared theta. So that's this part. Then we had minus 1. All right, next thing I want to do is rewrite, because there's not a cosine in the numerator. So I'm going to write this as 1 minus sine squared theta. So we're going to get sine of theta, sine squared of theta, sorry, minus 1 minus sine squared theta, and then just copy the rest down to sine theta plus 1. And in the denominator, I'm going to write sine squared theta as 1 minus cosine squared theta. So this is 1 minus cosine squared theta plus 2 sine theta cosine theta plus cosine squared theta minus 1. So I just substituted sine squared theta with this. Well, what happens is the cosine squared thetas cancel, and so does the 1's. All right, now let's simplify by simplifying the numerator, and this is all we have for the denominator now. So now we have, once we simplify the numerator, we're going to have 2 sine squared theta plus 2 sine of theta divided by 2 sine theta cosine theta. Let's go ahead and factor out this. They each have 2 sine. So let's factor out a 2 sine. And we're left with sine of theta plus 1. So what I can cancel out is the 2 sines. So what am I doing? So I have factored that out. Let me go ahead and write the denominator. 2 sine theta. I'm trying to jump ahead. 2 sine of theta. So I can factor this out. And 2 sine of theta divided by 2 sine of theta is 1. And now we're left with our desired result, this right here. So our final answer is sine of theta plus 1 divided by cosine of theta. And that's it. Thank you. Have a nice day. Bye-bye.